Hi everybody. So today we're going to take a look at a couple of problems that deal with simplifying rational expressions which have common monomial factors. So this first problem we're going to look at is this. It says simplify the following rational expression. We have 6x cubed divided by 15x to the fourth minus 60x cubed. Which values of x make the expression undefined? So the first job is to simplify this expression, and then the second is to find the values of x, which will make this undefined. Okay, so let's look over here. We'll do our work here because we have a lot more space than we do on Khan Academy. All right, so the first job is to simplify it. Now, in order to simplify this expression, what we must do is we have to first make it a little bit thicker. Okay, the first thing we have to do is to factor. We have to completely factor, top and bottom, the numerator and the denominator. Okay, so we have to completely factor the numerator and the denominator. And then we have to cancel like factors. All right. And then once we do that, we'll have the simplified version of this. All right. So let's do it. But before we cancel, I want to all right, what I like to do is put a little star here, put 1.5. What I want to do is identify, right? Identify ID values of x. Values of x excluded from the domain. Excluded from the domain. And I'm going to go into more detail on that, all right, as we go. So the first step, okay, let's completely factor the numerator and the denominator. So as we can see, the numerator is already a monomial, so there's nothing to factor. However, the bottom is a binomial. So if we look, we'll see that we have a common factor. We have a greatest common factor of 15 and 60, which is 15, by the way, because 15 does go into 64 times. So we're gonna factor out of 15, and then we have x to the fourth, x to the third. So obviously x to the third is going to be our common factor. And then let's write whatever is left after we factor 15x cubed from both terms. We're going to have an x minus 4, like so. Okay? And so step 1 is check. Now step 1.5. Okay? Let's identify the values of x excluded from the domain. In order to do that, we have to set the denominator equal to 0. So 15x cubed times x minus 4 equals 0. And we know that if we have two factors, let's say we have two factors a and b equals 0, right? A times b equals 0. We know that in order to get a product of 0, either a has to be 0 or b has to be 0, correct? So either a has to be 0 or b has to be 0. One of these factors has to be 0 if our product is 0. So likewise, one of these factors, either 15x cubed has to be 0 or x minus 4 has to be 0. So 15x cubed has to be 0 or x minus 4 has to be 0. And let's solve for x in both. We know that here, if you divide by 15, right, and then take the cube root, it's just 0, correct? Or just look at it. 15 times what is equal to 0? So this one is pretty easy. X is equal to 0, correct? And this one, just add 4, and we get x equals to 4. So here we have our two values of x that will be excluded from the domain. So in other words, x cannot be these two numbers. Because why? Then the denominator will go to 0, thus creating a undefined expression, correct? So x cannot be 0 and x cannot be 4. So let's write our restrictions in first before we go back to our problem. So in the second part, now we're going to cancel out. So looks like here we have x cubed on the top, x cubed on the bottom. So we're just going to cancel these x cubes here, all right? And then we have a 6 and a 15 here, so we know that 3 goes into 6 twice, and 3 goes into 15 5 times. So we're going to have 2 over 5 times x minus 4. Sorry about that, guys. That's the ice cream truck outside. Yes, it's almost 80 degrees outside. So it's 2 over 5 times x minus 4. That is our simplified expression. And our restrictions are right here. Okay? So we're going to type them in. It's 2 over 5 times x minus 4. So 2 over 5 times x minus 4. And then our restrictions where x can't be, it says choose all that apply. So we know it can't be 0 and it can't be 4, correct? So that is correct. All right, folks? All right. Let's do another one. Okay, we have an expression where Naledi and Duru manipulated the rational expression, and their responses are shown below. So both of them worked on the problem. They worked to simplify that expression, and they got two different answers. So which student wrote an expression that is equivalent to the original? Okay, so here, let's work on this. I'm going to try to work this right on Khan Academy. So again, we see that we have to first, we have to factor completely the numerator and the denominator. So we see that 12 and 48, well, we have a common factor of 12. 12 goes into itself once, 12 goes into 48 4 times. So we're going to have a 12 on the top, and then n cubed and n squared, so n squared is going to be a factor again on the top. That leaves us with n plus 4. Okay, let's do the bottom. Again, 12 goes into 60. 12 goes into 65 times. So again, 12 is going to be a greatest common factor. And then n cubed and n squared. So again, we're going to take out an n squared here. And that's going to leave us with n plus 5, like that. Okay? And we can clearly see, even though this question didn't ask us, I believe it didn't ask us, yeah. Even though this question didn't ask for our restrictions, we can clearly see that in the domain, n cannot equal 0, right, because of this term, and n cannot equal -5 because of this term. Again, whatever values of the variable make the denominator factors go to 0, those are restrictions to the domain. They create an undefined expression because you get 0 in the denominator. But anyway, they didn't ask this. But anyway, you know. And now let's cancel. So 12 over 12, these are now factors, correct? So you can cancel that. N squared over n squared, those are factors. You can cancel those. These you cannot. I repeat, you cannot cancel these n's here. You cannot do this. Why? Because these n's by themselves are not factors like these two terms were. They're not multiplied. They're added. N up top is added to 4, n on the bottom is added to 5. These are complete binomial factors. So these n's are not monomial factors. You can only cancel factors. Okay? The factors are n plus 4, n plus 5. They're not the same. Therefore, you cannot cancel. Okay? So therefore, our final answer is going to be just this, which means that Naledi has the correct answer. Okay? And Duru is incorrect. And as you can clearly see, what did Duru do? Duru went like this, right? He canceled the 12 n cubes top and bottom, mistakenly thinking that they are factors, when in fact they are not. They're added. They're part of factors. They're not factors by themselves. Okay, factors are multiplied. These 12 n cubes are added, so they're not factors. Okay, so therefore, Final answer, Naledi. Only Naledi is correct. And there you have it. Okay, let's do another one. We have 2y cubed over 2y to the fourth plus 16y cubed. Again, the same idea. Factor, simplify it, and then state the restrictions to the domain. Okay, what makes the expression undefined? This time, let's use red. And let's do it. Step 1. Factor completely. So 2y cubed, that's already factored completely. On the bottom, we have a binomial, so let's see what the greatest common factor is going to be. 2 goes into both, so we'll take out a 2, right? 2 goes into 2 once, 2 goes into 16 8 times. And then we have y to the fourth, y cubed. So the most number of y's we can take is 3 because this back term only has 3. Front term has 4. And then what's left? We're going to have y plus 8, correct? Like that. Okay, if you're not sure, just multiply. Distribute this and you should get the original back. All right, and now is a good time to do 1.5, which is find the restrictions to the domain. So we can see clearly that this monomial factor, y cannot equal 0, right? And in this binomial factor, y cannot equal -8. Again, any values of the variable that make those denominators go to 0, right? Denominator terms go to 0, thus creating an undefined expression. So those are our restrictions, and then let's now cancel. Okay, so we are now ready to cancel. So we have 2y cubed on the top, 2y cubed on the bottom, so we have 1 left on the top. Therefore, our final expression is 1 over y plus 8. Okay, I want to stress to you guys that you have to do 1.5 before 2. If you try to find the restrictions on the domain using 2, look, you're going to be missing the 0, correct? You only have y plus 8. The 2y cubed canceled out. So then you're not going to get the 0 restriction. So always find your restrictions before you start canceling. I repeat, always find your restrictions before you start canceling. That's why I called it 1.5 instead of 3. Okay? So let's type these in. First thing, let's type the simplified version. It's 1 over y plus, y plus 8. And our restrictions are 0 and -8. And that is correct. All right. Let's do one more real quickly. They just ask you which value makes the expression undefined. This is easy. Just look at the denominator. Correct? Look at the denominator and set the denominator equal to 0. This is your 1.5 here, right? Set this equal to 0 and solve for the variable. And it's very clear that y is 0. Therefore, y cannot be 0, right? And that's your restrictions to this domain. So let's plug it in. 0, y cannot be 0. Oh, oops. Oh, we have to do this too. Okay. So let's do the rest of it. All right. So it looks like on the top we're going to have 2y squared, leaving us with 3y plus 1 over 10y squared. Okay, and let's cancel it. So we're going to have y squared canceling. We're going to have the 2 going to the 10 5 times. So there's our final expression, right? 3y plus 1 over 5. Okay, so let's type that in. And 3y plus 1, whoops, got to do the fraction bar first. 3y plus 1 over 5. Okay, and there is our simplified expression, and here is our restriction to the domain, and that is correct. Okay, take care, guys.